Now to find the right window. There we go. And you should see my screen now.
Yes.
And did you get this pop-up, or are you seeing just the screen?
I can see the pop-up too.
This is awful. Such a worthless application. Anyway, yeah, wonderful to be here. This is not a picture of me. This is a picture of my dog. So I'm gonna skip back. This is me. I'm Andre. I'm the founder of Encore together with Marcus. Long time Go developer, backend developer. I was at Spotify for 8 years. And this is Salvador, a little puppy that we got a few months ago. He's incredibly playful and adorable. And so what we're talking about today is distributed systems, and really like a natural way of expressing them that is designed specifically for and with Go in mind. And so to step back and talk a bit about the problem. In my experience, building a backend is oftentimes it sounds really simple, but in reality, there's a lot of complexity that goes into it. It's large amounts of boilerplate. Like you have to do the same things over and over. You know, YAML files coming out of your ear. It's the same type of configuration again and again, and build systems and deployment systems, and connecting to databases and service discovery. And it's like you're just doing a lot of work to accomplish what often seems very simple. And there are many moving parts involved, right? Like when you're building a backend, it's not just like your code base and your business logic. It's, you have a bunch of infrastructure, you have a build and deployment pipeline, you have servers running that are provisioned somewhere, and deployments that need to update those servers, and then you want to connect those to other servers and to databases, and you want to make API calls to external things, and then you need like an API key. Like it's just like all of these things need to come together for everything to work, and it's very, very easy for things to break. And to summarize, like the end result is just what seems really simple is actually incredibly complicated. And it doesn't get any easier when you've done this once in production, you have to do it all over again if you want to have a test environment or you want to run things locally. So it just, a lot of time is spent not on writing your product, but on just things that surround that. And so to give you a bit more practical example, like most backend applications essentially look like this, right? You have a front end that is calling some backend API where you have your business logic. Maybe you make an API call to some other system or a third party. You do some processing and you store it in a database, and then you pass some data back to the user. And this sounds really simple, and it seems like, oh, we can build this in a day. But we're actually missing a lot of other components that go into doing this. So you want to have source code hosting somewhere. You want your build system that needs to talk to a deployment system that needs to provision servers and manage those servers. And then you need to provision a database server. And what's more is like at every step, you're like, we need API keys. We need everything to authenticate with everything else for security. And even if you do all of this, you're still not done, right? Like we haven't talked about documentation, development environments for like running things on your computer, test environments, like just boilerplate everywhere, monitoring, secrets, like the list is endless. And the problem with all of this is there's nobody to help you. There's nobody that actually takes all of this stuff and just says like, I've got it covered. The only person who actually cares about like putting all of this together is you, the developer. And the cloud provider is not going to help. Like, they don't understand how your things work. They're just say like, we're just giving you servers, you do the rest. And the libraries you use don't help either, because they have no idea where you're actually setting things up. It's not connected to the cloud, right? And so you have to do the work. And like instinctively, you might think like, oh, there's this infrastructure as code concept, right? Like that might help us here. And the idea is like, instead of just going into a cloud and setting up a bunch of servers, what you would do is you would write some code to help you provision all this. And there's a few different options. There's Terraform, there's CloudFormation, there's Pulumi. They're more like coming every day. And it looks usually something like this. This is from Pulumi. And this is great, but the downside is like, it's generally just focused on production, right? Like, even if you write all of this code, that's only for setting up a production environment. If you want to do like a test environment, it usually looks quite different from a production environment. And if you want to do it locally, it's different again. And what's more is like, it's just more code, right? Like, you have to just write even more code instead of doing less work. And thirdly, it's like, there's nothing that is connecting this to your application. So over time, it's quite easy that it goes out of sync. And so what I realized when I was trying to figure out what to do about this is like, when you look at a system and like an architecture diagram, it's pretty straightforward to understand like how you would turn this into infrastructure in the cloud. And you would say like, oh, we're going to take these services and we're going to deploy them in like Kubernetes or whatever. And then each service has its own database. So that's going to be, we're going to provision that, and then we're going to connect them together, and we're going to put a load balancer in front, and you're done, right? So what we really would like to do is we want to find a way of expressing, like, going from architecture diagrams to infrastructure in production. And that would allow us to skip like all of this nonsense. So I had a bit of a crazy idea where, like, what if instead of doing all of this work, we would just find a way of expressing our code in a way that lets us create an architecture diagram automatically. And once you have that architecture diagram, we can then use that to set up all the infrastructure in the cloud. And so what would we actually need out of that? Well, we would need to understand, like, by analyzing the code, we would have to understand things like, what are all the services? What are all the endpoints? What are the request and response schemas of those endpoints? API calls, secrets, and so on. And on the infrastructure side, we would want to know, like, what are all the databases? What's the structure of those databases? Where are you querying the databases? And then things like, other pieces of infrastructure, like when you're using blob storage, like Amazon S3 or Google Cloud Storage, where you using caching and queues and PubSub and so on. So if we could find a way of expressing these things in code so that we can actually understand this, we could just turn that into an architecture diagram, and then we would take that and turn that into like provision and manage all the infrastructure. And what I realized is this is quite similar to how a compiler works. Like when you write Go code, like you see here on the left, what happens in the compiler is we first build up a syntax tree, which is like a tree representation of how everything works. And you have like functions and if statements and expressions and so on. And then we take that syntax tree and turn it into machine code that the computer actually runs. So I realized that what we want to do is essentially the same thing, but instead of turning it into like functions and expressions, what we want to have is a tree of where the concepts are like distributed systems concepts. So you would have services and databases and endpoints and so on. And what we would then do is we would, when we actually compile it, that would mean like we turn that into like provisioning infrastructure. So we set out to build that, and we're calling this the Encore application graph. And it's essentially like we enable you to write really natural looking Go code. And then we have a parser that turns that into a syntax tree. And then we take that syntax tree and we produce like graph like this. And from that, we can actually do lots and lots of interesting stuff. But a really big use case is provisioning infrastructure. So let's take a look at what that looks like when you're writing Go code. I'm going to exit the presentation real quick here and open up my editor. And so what we're looking at here is a really simple Go project. It essentially has nothing in it.
You're still on the presentation though.
Oh, I didn't share my whole screen. Okay. There we go. And wonderful. So what we're looking at here is a very, very simple application. There's literally nothing in it. I just added a single package with a single file. And what I want to demonstrate is like how we actually can express distributed systems concepts in a very natural way. And the first thing we want to do is we want to create a service that has an endpoint. And the way you do that with Encore is by defining a function. So you would write like Encore API public, and then you would say function create, and you would give it a context, and then you would give it like some input. So say create parameters where we take in, let's say an email, and that's it for now. We're not gonna get any more input. Create parameters, and we're going to return an error. So once I hit save, on the right-hand side, this is running in the background and analyzing the code as I type it. And then you can see that from this description, Encore understands that this is actually a service, and it's the user service. And we can do this again, and we can create a new service. Let's call it payment. We'll call it the payment service. And you can see now that there are two services. And here, instead of creating something, let's call this send money. And we're going to say send it from email to email. Send money params. And we're going to do send money parameters. And just to demonstrate, like when you're doing this, let's say that if we're going to create the user first. So we would do with Encore, we would say, I need to import it. Encore.app/user. And once you import it, like the way you express this with Encore is, since we define APIs as functions, it makes sense to do API calls by doing function calls. So with Encore, you simply import the package and then you call the function on it. So in this case, it's Encore user.create. And we'll pass in the parameters, and we would say email is the from email, for example. And we'll get an error back, and we can return that as an error. So now when I hit save, you can see that Encore understands this relationship, and it adds an arrow from this service to the user service, because we're actually calling it from our payment service. And if I go ahead and make this private, you will see that the arrow from the load balancer goes away because it's no longer accessible to the outside. So this is a way of representing this, and we can do more interesting stuff. We can say that we're going to have some database migrations. I would say create table user, and we're just going to have a single column. And in here, we're going to say, we're going to import the SQL package from Encore. And we're going to, when we create a user, we're going to insert it into the database. And with Encore, you don't have to do anything besides like using the SQL DB package. You don't have to set up the database in any way. So you would say query, we can just use exec. It would say insert into user. This is just a standard like standard library syntax. And once you do that, you can see that Encore understands this relationship and adds a database to this picture. So this is really how Encore understands your application, and every single thing you do, it will just immediately understand and figure out like, okay, so this is how your system looks like. So then we can take this, like the underlying representation, and do lots of interesting stuff with it. And so to go back a bit to our presentation, how would we actually accomplish this? Because I think that's the most interesting part. So what we want to do is, first of all, we want to parse the code that you're writing. Then we want to compile that into this graph. And with that graph, we're going to rewrite the code that you're writing and actually turn it into a distributed system, so that when you're actually running it in the cloud, it's working like a distributed system. You have multiple services and they're talking with each other over APIs and so on. And finally, we're going to use that to provision all the necessary infrastructure. So to show you a bit how that looks like, I'm going to go back into here. I'm going to close this example. And this is like, just to give you a taste of how everything works. It's a bit too much to really understand in such a short amount of time. But I want to show you, because all of the stuff I've showed you it's completely open source. And so this is open, you can check it out on GitHub. We have a few top level concepts. So we have this parser that we talked about. We have the compiler, which is actually doing a bunch of code generation to make this work. And the application graph is available in the protobuf. So you can see here the metadata package. This is actually where we express the application graph, and you can see all the concepts like we have find RPCs, and the way it works is in the parser we do like a lot of static analysis. So we take all the Go files in your project and we turn them into a syntax tree, and then we do like a lot of code analysis to figure out like how things are working. A compiler where we take that graph and we rewrite the code and do a bunch of code generation to turn it into like an actual API call. So here is the file that actually is doing all the code rewriting, and we walk over the syntax tree. We pull out like where interesting stuff is happening, like where you're doing an RPC call between APIs, and we rewrite it to like an internal wrapper function. And then here's a template which is actually the definition of what that function looks like. So here we can see we are calling the runtime to actually begin the API call, and so on. So like this is quite detailed, but hopefully it gives you a sense of how things work under the hood. And with that, I'm going to jump back to the presentation. And yeah, so what I just showed you is like the core idea is this, that we go from Go code, and instead of compiling it to or parsing it to an abstract syntax tree, we parse it to like an Encore syntax tree, which is has concepts like services and databases and endpoints and so on. And once we have this syntax tree, we can turn it into this graph and infrastructure, but we can actually do a lot of things with it. So we can do things like, we can provision all the infrastructure like we talked about. We can generate a bunch of code, but we also do like generate API documentation or provide distributed tracing for your application. And to give a better sense of how that works, I want to move
You're
on
breaking up a bit, Andre.
from like a project to give. Let me. Is it better now?
Yes, yeah, it's better now.
Okay, sorry about that. So what I want to show you real quick is like how you can actually use Encore to build like a real world application. And the first thing you do is you install Encore, and then you type Encore app create, and now you give it a name like Chicago Meetup. You can pick a template. So we're going to pick a Trello example. And what you then do is we can open it up in Visual Studio Code. Are you seeing my screen, by the way?
We were, now it's gone.
Okay. Let me just share my whole screen. It's going to be. So with Encore, you would just type Encore run to actually set up your application. And what that does is it does all the code analysis that we just talked about, and it registers all of your endpoints. And like I just showed you, like the way you actually do that with Encore is you define a function, and with that function, you just give it this annotation. And that's enough for Encore to pick up all of this stuff. And if we take a look, Encore comes with this really awesome like development dashboard where you can get pretty interesting stuff. Like you get fully generated API documentation for everything your application does. So all of your APIs. And here you can go and we can look at this API that we just saw. You can see that Encore pulls out all the parameters of your like inputs and outputs of your API. You can call it directly from here. You can see that you get the response. We can call some other APIs and see how that works. And if we go back here to this view, we can see the API calls we just made. And so another thing that Encore does is it adds a bunch of instrumentation to your application. So here you can see that the API calls I just did, you get this really, really detailed view of exactly what happened. So here is the board.get, and you can see that like what happened, right? So this API call made a database query. It took 6 milliseconds, and then it made 2 API calls. And here we're calling this API. And at the same time, like we called this API. And this was in 3 different Go routines. You can see here on this timeline that we first did this database query. And once that completed, we made these 2 in parallel. If you want, you can click on this to get like a stack trace, where exactly in the code this happened, and so on. So this is incredibly powerful if you want to find like where is the bug in my system, or what part of my application is slow. And once you have that and you want to actually deploy this to the cloud, you just type git push Encore. And what happens then is it will send it to our cloud platform. It will like parse, compile, run all the tests, set up all the infrastructure, and deploy it to the cloud. There's nothing you have to do. It just works. So once these tests are done, it will provision all the necessary infrastructure, and then it will deploy it. And once it's live in production, you just get completely like out of the box. There's no work needed. You get like metrics, you get logs, you get tracing that we just talked about, you get API documentation, you can browse the code, like all of this just works. There's nothing more to it. And yeah, that's basically a walkthrough of Encore, a lot of like how it works under the hood, and the sorts of applications you can build on top of it. And just to demonstrate, like actually I have a sample front end that you can play around with when you, like, if you use the Trello example, it will show you that all of this is actually like working as you would expect. So you can create a board, you can create columns, you can drag them around. And if we go back here, you can see that what I just did made a bunch of API calls. So all of this is like a fully functioning Trello application. And now everything has been deployed. It set up everything in production. And now my application is live in the cloud. And if I want, I can call it, here's like a production URL. So instead of in this showcase, I can also connect it to my cloud. And then you would say like, And now instead of talking to my computer, it's actually talking to my cloud. And here you can see that it's making requests to the cloud production environment. You would say, yeah. If we go back here, we're going to see that it's streaming logs too over here. So yeah, that's all I wanted to show. Happy, of course, to take any questions.
How long it took you to build all of this? That's a lot. And doing this end-to-end, adding tracing instrumentation on the fly and everything.
Whew, I've been working on this for 3.5 years by now. Just to like really build out the foundation of all of this, because I think to really get the best experience, you need a lot of these like benefits, so that you don't actually have to do all of that. Like people actually want this stuff, like build systems, deployment systems, tracing, API documentation. There's lots more as well, but you don't want to spend time doing that yourself. So that was like a big part of what we've been working on, is building up all of that so that when you use Encore, all of that stuff just works and you don't have to do it yourself.
When you provision on a cloud, either like, I'll use AWS as an example, into Kubernetes, that does not exist already. I did read the README on the GitHub. Is it going into like Amazon Kubernetes engine where it's managed, or the non-managed EC2?
Yeah, so right now it's using the managed version. Just like in general, like our belief is that developers should be spending as little time as possible on managing infrastructure. So that's kind of the idea. We're actively looking at more like flexible deployment options. So you could say like, oh, just deploy it to, like, I don't want a Kubernetes cluster. You can just deploy it directly to a VM, and that's fine. Like we want to support those sorts of use cases as well.
I just want to confirm. So we can own our own virtual machines. We can do this on DigitalOcean or AWS, right? It's not on.
Yeah, so right now we don't support like putting it on a virtual machine. It is spinning up a Kubernetes cluster if you deploy it to your own cloud, but that's like high up on the list of what we want to support, so that you have that flexibility, like whatever deployment option makes the most sense for you, we want to support. It's more about like, don't spend time orchestrating all of that. I'm not sure, did that answer your question, or did you, was there like a follow-up?
It does. Why when you say Kubernetes, so does it running like a SQL database that's part of the system as well? Why can't we just knock it down to one executable and use like a, I don't know, like a DynamoDB database or something like that?
I mean, when you use a SQL database with Encore, then it sets up like a managed RDS database. So the idea is like, yeah, depending on the environment, it will be set up in different ways. So for example, when you're setting up like a production environment, then we'll set up like a fully managed RDS database, so that you have like backups and reliability and SLAs from Amazon. If you set up like a test environment that is much more like, you want it to be low cost and not like fully managed, super reliable, then we set it up like actually in a Kubernetes cluster, so that you don't incur all of those costs. And then on your developer machine, we set it up just like running in a Docker container on your computer. So exactly how it sets up the infrastructure depends on the type of environment, just to be more flexible. And you asked about DynamoDB. That's also something that we want to support. It's trickier because there's no great, like, DynamoDB is specific to Amazon, whereas Postgres is more, you know, every cloud provider supports Postgres. So that's where we started. But definitely want to add like more infrastructure options. And yeah, and to be clear, like single binary, like Encore is all about like building distributed systems. So every service becomes like a static binary, like you would expect from Go, but it's really about solving the problems when you're actually not writing a single binary. You're actually like building larger systems.
There's a bunch of questions in the chat.
Actually, I have a quick question before you jump there. And I was multitasking a little bit, so I apologize if you covered this. I think I read that you have the ability, or Encore will create preview environments from PRs. I'm curious the level of control or knobs to how much duplication of the backend infrastructure is for those preview PRs.
Yeah,
previews.
so I mean, when you set up a preview PR, for everybody who hasn't read this documentation, like when you use Encore and you can integrate it with GitHub, right? So you link your GitHub repo with Encore, and what will happen is when you then create a pull request, Encore will of course like build it, run the tests and so on, but it will also create a dedicated test environment for that pull request. And that makes it super easy if you want to verify, like, is this change actually fixing the bug? Or you can say, like, I have a front end which is talking to my Encore application. You can just reroute it and say, instead of going to my production environment, route the front end to talk to this PR. And you can verify all the changes and so on. And so the question is, like, what does that actually mean? Like, what does it set up, right? Is it a full-blown environment? And we're approaching that in the same way that we're approaching like developer environments. Is we're setting up like everything for a preview environment in a much more lightweight fashion. So it's a very small, like if you're using a database, it's a very small database. It's not like auto scaling to infinity. It's like single instance running fairly low, like CPU quotas and so on, because we think that's what you usually want. Like for a PR environment, most of the time it's actually going to be inactive. So we want to scale that to 0. We wanted to use very little resources. And then that's kind of how we're thinking about it.
Yeah. So it would be complete instantiation. And then I guess in terms of like injecting test data or running tests against that, is that something you have support for?
Yeah, we want to add like native support for that. Right now, the best way to do that is to treat the test data like any other database migration. So you can say, like, you would say like, okay, so the base migrations are like, we're creating all the tables, and then you can have one which is just like adding a bunch of test data. And in production, you can skip over that one. So it's considered applied, but you don't actually apply it. So then every environment that you create besides that production environment will apply that. And then you get like pre-populated data.
Very good. Thank you.
I like that. It's first of all, it's an amazing tool. I'm not a computer scientist. I'm just a sysadmin who we do a lot of code, and Go is something I've been kind of curious about. I came from like a PowerShell background, but I like Go. So to have it help me visualize what I'm building is great. And I was looking at the price points. It looks like we can start using it right away. everything gets pushed up to your cloud. I think I'm understanding that, but below a certain resource level, I think everything is free, but then the big jump to $99 a month and then some custom stuff. I'm curious how this plays in a team environment. A couple things like that. And then it's hard to read through. It's a lot of info, but what's the major difference once you go pro?
So it's really primarily about scale, right? Like, I mean, what we want to create is the best developer experience and the most productive experience out there. And I think we absolutely want this to be something you can use for free. Like, this is not something about like locking you into paying us. It's about like, we want to provide you with that experience. And if you want to use it in like an enterprise setting, like you're actually using it to build commercial stuff, then like we're going to incur a lot of charges, like, or costs to actually provide that service in terms of like build, deploy, managing infrastructure, like all of this sort of thing. And in that, it also includes like a fair amount of like we think about it as like fair use. Like, we want you, like, right now we host all of the like test environments and so on just for convenience, because setting that up in your own cloud is annoying, and like the baseline price for that is fairly high. Like, you actually can't really get like a managed Kubernetes cluster to be very cheap. So that's really how we're thinking about it. And like right now in practice, it's primarily like the pro tier is primarily about like commercial use and just bumping the like retention on things like logging, tracing, metrics, as well as having additional concurrent builds, right? So if you're a larger team, you want to build multiple things at once, you like everybody's creating pull requests all the time. You don't want to have like every build like being queued, but that's what we have to do for the free tier, just so that we can actually have like a limit on the resources that we provide, right? I hope that answers your question.
It did, thank you.
Let's see, there are some more questions in the chat. Can you mention any high profile companies or projects that are using Encore in production? So I don't want to speak on behalf of people. I don't have the permission to say about it. There are some we can mention. One is, I think the most high profile is, we've actually seen, like, this is not live yet, but we have been working with GopherCon to, like, they've been working on like an open source platform for like running their conferences, and they've been using Encore to build that platform, and they intend for that to be like fully open source and available to anybody, as far as I understand, but it's also like a work in progress. So I don't want to speak too soon about that, but since it is open source, I think I can share it.
I was trying to envision how you could do protocol buffers, gRPC, to talk to Flutter apps. So if you're building all this stuff, theoretically, it would also generate a protofile. Maybe you could even generate the Dart library and just drop it into a Flutter project and do. I'm just thinking out loud. So
yeah, no, it's a great question, and that's actually something that I can show very briefly. We do already support generating front-end lines. And what we support right now is TypeScript lines. So Oops. So here, for example, you can just type Encore generate client, your project ID, and then the output file. And in this case, it's a TypeScript file, so it will generate a TypeScript client. And you can see here that it generates like a fully type-safe client with all of your services and the parameters. It's fully documented, has all the information you need. So like once this is generated, all you have to do is write like a new client. You can specify the environment, and I guess I need to do it below. And then you can just do like client board dot create, and you get autocomplete on everything, right? Like this already exists for TypeScript. We want to add support for more languages. That's actually a really, really simple thing to add support for. So it would be super easy to add like Flutter or Dart support to this, and then that just works for your application. In terms of protobuf and gRPC, that's also something we want to add. What I'm showing you right now is for like the existing APIs, which are HTTP and JSON for like public APIs. But we also want to add like gRPC support so that you can call it via gRPC.
Curious even about the graphic. Again, like the whole compile to image is awesome. For the graphic that it's generating, are you somehow pulling, for instance, like AWS or GCP, are you somehow pulling that image, or is that a custom that it's updated? If somebody does like a pull request, hey, add this, add that, is that how that compile based on the type is generated?
When you say image, you mean the like visual I showed you with this system, or?
Yep.
Yeah. So actually, to be perfectly clear, like that's not something that the framework just generates. We want to do that because I think it's valuable, but I don't know if it was clear, but it's a pretty rough implementation of like it's using GraphViz under the hood with like custom images, and it's more to demonstrate, like to try to visualize what the static analysis produces, and what it's essentially doing is it's just like I wrote that tool in like 10 minutes, and it's just using like the open source parser that we have to take the code, turn it into like the application graph, and then we're just walking that graph to produce like a GraphViz output. I think there's like this Go graph, like I don't remember what the project is called. So yeah, I would love to say that all of that is actually done. It's not. It's just like it's a good way of visualizing what Encore is doing under the hood, and we want to take that and turn it into like a more polished version for sure.
I mean, ironically, you know, the $1 billion piece of art that sold was really just a brush cleaner. So
Fair enough.
I mean, there are other features. The testing feature built in, the fact that it's focused really on cloud native. For me, I think the sales point is the graphic, because that's what I've been missing as a developer. But the other features are also very solid.
I mean, in that case, I'm happy to spend another another hour on the graphic. I really agree with you. I think it's super compelling. It's just like we need to spend a bit more time actually getting the like really about like the layout to be useful, because once you do it at a larger scale, the built-in layout engine becomes very, very poor. So yeah, I mean, if you think it's that helpful, then we should definitely spend more time on it.
Well, this is open source, but it's got a production value behind it. So if people want to volunteer, how does that work out?
Yeah, absolutely. Like all of it is like all the stuff I showed you in the beginning. It's all open source. The parser, the compiler, the runtime, the tracing, like everything. And yeah, I mean, we more than happily would love contributions, whether it's that, which is just like another aspect of leveraging this like underlying understanding of how your application works, or like adding Dart support to the front end client generation, like all that sort of thing. I think are very, very great like starter tasks or issues that would be super valuable, I think, to. And what I think is really cool about Encore as a concept is once you add a feature like that, it's immediately useful to everybody that are building Encore applications. Like there's no work that people need to do to get that value. You can just say like, oh, with this new release, you get out of the box this really awesome visualization of your system.
That's all is really cool, and like folks already asked like many of the questions that I wanted to. Is there any other question in the room?
Could you show that Trello example again?
The which aspect of the Trello example?
I was kind of curious, the JavaScript part, like it looks to me like you've got some sort of multiplexer, like you're hosting a website in the system, and I was kind of curious where you kept the code.
You mean this part?
Yes, that part.
Yeah, so this is like when you create an Encore application with a command line, we have a few different templates. One such template is this Trello project that I showed you. Like this is the backend code for that. But because it's so hard to understand what a backend does without seeing the front end, we built like a sample front end for that. And this is just like, you're just telling it like connect to my computer or connect to the cloud application, like the cloud environment. And if this is just using like, it's a client-side application, so it's just making an HTTP request to localhost. So my browser is calling my my local port, and because the port is standardized, like an Encore application always starts up on port 4060. That means that this is just calling it on 4060, and then this is just like a super simple React application. And this is just making API calls to the backend, like you can see here. When I'm refreshing this, you can see that it's making API calls. So that's really how it works. There's nothing strange about it.
I'm not a React developer. I'm kind of curious, what library are you using to get the drag and drop feature going?
Oh, it's called, I think, React D&D, drag and drop. I hadn't used it before. Drag and drop is like, I'm not a front-end developer, and it was like, oh, this is going to be tough. But that library was surprisingly helpful.
I gotta try that.
And I guess another thing we didn't really touch about is this, like, what's really nice when you, like, with Encore, you're treating like packages become your backend services, right? So to make an API call, you just import it as a package. And to make an API call, you just call the package function, which is defined as like an Encore API. And that means that you get like all the benefits of it being a function call. Like you can just autocomplete like so. And you get autocomplete on everything. And if you screw it up and you say like you pass in the wrong name of a field, you actually get like a compile time error saying like, hey, you're sending in the wrong data to this API. So you never have to worry about like, am I sending the wrong data here? Or did I get the like field name wrong? Or like if you think like, oh, this wants a string instead of an integer, you will get a compile time error as well. So it becomes like incredibly easy to make API calls, but they also become type safe, and the compiler will tell you when you get it wrong.
And this comes prepackaged. So with the brew install, or once you open, VS Code recognizes Encore and will kind of add little bits if necessary.
Yeah, it's actually we want to add like even more to the editor experience, but this is actually the built-in like Go autocomplete. We're not doing anything because like the way we like what I mentioned is like we're trying to make these concepts as natural as possible, and that means that this like autocomplete I just showed you is actually Visual Studio VS Code thinking that this is like a regular API call. Like from a Go language perspective, it is, right? Like you have an import of a package, and then you're calling a function. So this is just like standard VS Code auto-completion. And you would get the same experience in Goland or Vim or Emacs or whatever you want to use, as long as you have it configured with like Go language server. So the way Encore works is we're just like, it looks like a function call to the editor. And then when we actually compile your application, that's when we swap it out for a real API call. So you get like the best of both worlds, essentially.
I'm going to go through code because you are doing so much here, but I'm actually a little bit interested in like how are you creating that tracing UI? Because I don't think that's Jaeger or something else. Is that like something that you build yourself?
Yeah. So I can show that again. Yeah, so like when you run Encore Run, you get this developer development dashboard. If you open that up, you get to here, and here you can see like your API documentation and so on, and all the requests that are happening. You get this tracing view, and yeah, we built this entirely from scratch because like what I think is so powerful about Encore's tracing is we actually understand what your application is doing. Like most tracing implementations just say like, here was a span, this called that. You don't have any idea like, oh, this is a database query or this is an API call or whatever. But Encore understands exactly what's happening. Like there were 2 API calls and 1 database query. And this is the database query. And you can click on it to see where it is in your code. And you can see the requests of everything. You can see the responses. Like this is not the level of detail you usually get from tracing.
Yeah.
But because Encore is so like Go specific and so like integrated like into the language itself, we can do much more than normal tracing implementations. So we're
it's not
using
open
that.
telemetry, right? It's like it's not open telemetry, or you are not using open telemetry spec.
No, we're doing like all this instrumentation at compile time and instrumenting it ourselves, and then we because we capture so much more information, and we are actually doing it at like the language runtime level. It's both like we're getting much more data than you do with open tracing, and it's actually much more performant because it's doing it like at a very low level. It's way faster than traditional tracing as well, and it would be possible to export it in like an open tracing compatible way, but then you would lose out on like a lot of these benefits, because those if you send it to like a Jaeger server, it would actually not understand like all of these concepts, like here's a database, this is a stack trace, this is the query, here was the response. Like you would lose out on a lot of that value, but we certainly could do that.
But then the next question comes, like tracing is very resource intensive in terms of like storage and everything. So if somebody uses Encore to build a service that has like, you know, millions of requests, let's say per minute or something, not second, but that will kind of overwhelm this UI now.
I mean, this UI is specifically for local development, so hopefully you don't have millions of API calls on your own computer. For production, like, you know, it's still like a work in progress, but there, like, it's certainly not a problem to handle that scale, right? Like we've built very scalable systems at Spotify, and like handling like tracing at that scale it's not a problem. And I will also add, like, because we're doing this at like a very low level, we're actually doing fairly advanced like compression, so that we're actually not sending that much data in the first place. Like this, like a stack trace like this, especially when you have like multiple functions and so on, like normally that is really, really big. But we're doing this, we're actually just storing the address of the function. So we're actually like creating a stack trace like this. What's actually being sent on the wire is like 2 bytes per stack frame, essentially. So this is like 4 bytes to send this. So we can do like a lot of that crazy stuff just to make it really, really efficient.
Okay. Cool. Yeah, that's very cool actually. All right. Any more question?
I don't know if you guys are familiar with the Windows system internals. So when I saw that back in the day, I was really impressed, and the level of understanding that his tools would show off the system, and then seeing this. So of course, I'm curious about your background, where you're able to produce these tools really slick, but to understand and how to really get to where the code is doing its thing, and then to visualize it. So I'm really curious about your background as well.
Oh, thank you. I mean, I've done a lot of everything. I guess my main experience like has been at Spotify, but I've programmed for a very long time before that. So I started like, I think I was 10 and I was programming for World of Warcraft and like making user interfaces for that. And then I moved into web development and backend development and made a bunch of stuff when I was like 14, 15 that were pretty popular. And then studied computer science. And then after that, I jumped on Spotify. And at Spotify, I've done like everything essentially, like infrastructure, transport protocols, a lot of like backend development, like the sort of thing that Encore is optimizing for. Like that's my main focus. But then also like I built out a lot of Spotify's Go infrastructure. So things like internal libraries for doing like transport protocols and distributed systems, build systems, deployment systems. A lot of like internal Go tooling. Then I actually did a talk at GopherCon last year about how I did a lot of like, some of the teams I were in were working with Python. So I built like a Go, like a parser and a transpiler to automatically convert Python code into Go. So that was a very interesting project that I worked like on for several years. And there I got a lot into this sort of thing, like static analysis and code generation and so on. And then I've done like a lot of web development, a lot of data, machine learning. Yeah, definitely done quite a bit of everything over the years.
Yeah, no, this is very cool, and yeah, thanks a lot. This is amazing. I will read the code to understand some of the bits that you are doing out there. But thanks a lot for your session. And
Yeah,
thanks
good
for
job.
everybody for showing up.
Very
Yeah.
good job.
I mean, yeah, it's been a real pleasure, and thank you so much for listening and for asking such interesting questions. It's just really fun to talk with people who are so engaged and just interested to learn more. Like, super appreciated.
Best of luck to you for the project. I think we'll see a lot of traction because it's very interesting. Like, you know, it kind of handles everything. So thank you.
Yeah.
Thank you very much.
Yeah, and thank you. Like Marcus mentioned, like if you have any questions for us, just you can join our Slack. You can ping us on GitHub, or just email us. We'd love to hear your thoughts. I'll put my email in the chat as well. And thank you so much for this. It was a real pleasure.
Thanks, Andre. Have a good one. Bye.
Bye, Andre.
Thanks, Andre. Great project.